Okay. So, one thing I can do, once again, when we're dealing with all polynomials, we may have options other than applying the product rule, applying the quotient rule. For example, something like x squared plus x over 1 is the same as x squared over x plus 1 over x. Which is the same as x plus x to the negative 1. Just another way to write that function. X squared plus 1 all divided by x squared. If I take each term of the numerator divided by x, x squared divided by x simplifies to x. 1 divided by x, I rewrite as x to the negative 1. We're going to want powers. We want things written with powers, with exponents, if we're going to use the power rule. So from there, my derivative, the derivative of x, is 1. And the derivative of x to the negative 1 is negative 1 x to the negative 2. And so that would be a completely appropriate derivative to write. Another option x squared plus 1 all divided by x is x squared plus 1 times x to the negative 1. So that's a product. All right, apply the product rule, and let's see if you get the same derivative. See if you can do the product rule for that, knowing that your derivative should end up being equivalent to 1 minus 1x to the negative 2. How are we going to do product rule? The little product rule work. You can look up here if you want, or you can keep working. You can look up here for a clue. Now, something that starts as a quotient that you rewrite as a product, you're going to get pretty deep into some negative exponents. That's what's going to happen on this one. F being x squared plus 1, f prime being 2x, that's not too bad. But if g is x to the negative 1, g prime is negative x to the negative 2. And then you start simplifying. I mean, really, once I write my derivative out, g f prime and f g prime, you know, you're going to get tired of me saying this, but after I wrote that out, my calculus was over. The calculus part is done now. Now I am just going algebra, straight algebra, not even, I mean, this is technically algebra 1, multiplying using negative exponents. I mean, you do more of it in algebra 2. So this would be 2x to the 0. When I multiply with the same base, I add the exponent, plus negative x to the 0 plus negative x to the negative 2. Whew.
How do you get negative x to 0?
I took negative x to the negative 2 times x squared. So that's negative 1 x to 0. Hey, don't worry if this part's, if you're like really miserable doing this one, because in a minute quotient rule is going to save you. All right, so let's look at this thing with all these negative exponents we put together. The 2x to the 0 is equal to 2. Minus x to the 0. X to the 0 is 1. Plus negative x to the negative 2. I am going to end up with the same derivative. Just throw a 1 there and they'll look identical. That guy does look just like that guy. I mean, definitely harder to get there, for sure. A lot more exponent love to get there. But you can get there. You can make a quotient into a product. Dividing by a function is just multiplying by its reciprocal. So when we were dividing by x, if I rewrite this as multiplying by x to the negative 1, which is the reciprocal, I have a product and I can do product rule. Or, let's remember what this was. X squared plus 1 over x. I don't have to change my problem at all. I can take the problem the way it's presented. I don't have to rewrite it. I don't have to rewrite it, simplify it out. I don't have to rewrite it as a product. I can take the quotient I'm given and apply the quotient rule. All right, so quotient rule relies on us looking at the two functions, calling the numerator one f and calling the denominator one g. There's also versions where we call them high and low, you know, high up in the numerator and low down in the denominator. That gives you a nice little rhyme for quotient rule. When I do quotient rule, I start with the denominator function. I multiply by the derivative of the numerator, so gf prime, minus, instead of plus, fg prime. Notice that's the same set of terms in the product rule, except a minus instead of a plus. Gf prime, fg prime, with a minus, all divided by g squared. The order 100 per million % matters. because you are subtracting, flip-flopping those two chunks of terms and doing FG prime first, not going to give you the right answer. That's why I recommend when you learn your product rule to learn it in this order, because then you're halfway to quotient rule. If you know GF prime, FG prime, and make up a sentence or do something and put something in there to help you remember those are primes, whatever. You know, it's GF, FG, and the second ones are primes, whatever, however you need to do it. If you have that basic order, the subtraction sign and G squared in the denominator, and you've got quotient rule. All right, so here we go. So remember, F was x squared plus 1. G in this time is x. Notice I don't have to go to negative exponents. It's just the function that's sitting in the denominator. I don't have to rewrite anything. So F prime is 2x. G prime is 1. And here I go. Yes. F. G prime divided by G squared. Now this would make me super happy if once I put all those pieces together, I actually ended up with the same derivative that I got using those other two techniques. You know, I mean, I got 1 minus 1x to the negative 2. I got 1 plus a negative 1, which is the same as 1 minus x to the negative 2. I got the exact same thing from both of these approaches. This approach has to give me the same thing or it's no good. Let's see how we did it. This part is 2x squared. We're going to multiply by 1 and subtract each of those. So we're going to get minus x squared and minus 1, all divided by x squared. Just kind of reminding you what the answer was that we got before. Okay. Here we go. So this will be x squared minus 1 over x squared. Okay, so 2x squared minus x squared is x squared. And then if I split that up into two fractions, that's 1 minus 1 over x squared is x to the negative 2. You're going to get the exact same answer. Yes?
If this question was on like a quiz or a test, can we just leave it as 1 minus 1 over x squared? Or should we put it up there?
You can leave it as that. That's fine. Yeah. That's going to be the tough thing sometimes with these quotient rule problems is knowing when to stop. Like, how much do I need to do to, like, fix up the answer? So here's what I'll use as my guideline. Number one, if it's multiple choice, I'm looking for the right answer. So if I get to a certain point and I look and I don't see it, I might just need to do more simplifying. If it's a free response, I would always stop with it still in a quotient. Okay. sometimes in a problem with a free response, it would say, show me that the derivative equals this. Okay, so you know what you're going for. You know what it's supposed to look like. Now, can you do the algebra steps legally? Can you do the calculus and the algebra to get there? Any of these versions of these answers, this version, are considered correct versions.
So 1 minus 1 over x squared would count.
1 minus 1 over x squared would absolutely count. And x squared minus 1 over x squared would count. And 1 minus 1x to the negative 2 would count. They would all count. That's good when it's come up with your own answer, because you've got a lot of freedom in writing your final answer and still being correct. It's a little harder when it's when it's multiple choice, because you've got to figure out. So if you get here and this is the choice, like, you've got to be able to get from here to here algebraically. All right. So, bad news on quotient rule. It's kind of a pain. Good news on quotient rule, you hardly forget to do it, because the problems that you have to do quotient rule on are very obvious. They're big, scary, rational looking function things. So it's very unlikely you're going to not know that you should be doing quotient rule. Product rule is easier to skip. Quotient rule kind of yells at you like, look, I'm a big scary quotient. Okay, I'm doing a quotient rule. But they're kind of a pain to do. Right, lots of little pieces to deal with. So this just has a summary. Like I said, this is the high-low memory tool is the one that's kind of common. For some reason, my calculus teacher liked to do hi and ho, because he'd like to say ho ho, and then he would say Merry Christmas. Or he would make us recite it, and after he said, he goes, hey, you sound like Santa. I don't know why. He was a nut. Mr. McCorkle. So I always remember it like this. That's why I put it like this on my notes, with the numerator as hi and the denominator as ho. The more common sort of way to remember it, like my dear Aunt Sally way, is high and low. So low d high minus high d low over low low. Denominator, d for derivative of numerator. High is the numerator, derivative. Low is the denominator, denominator squared. All right, to save time, or to maximize our time, we're actually going to skip example 9 because it's kind of a boring one to do. But let's do example 10, because the only way to do example 10 is quotient rule. Let's write that derivative of number 10 using the quotient rule. Find y prime. It will not tell you to use quotient rule. It will just say, hey, find the derivative. And you will have to look at that and go, oh, look, it's a quotient. Yuck. I'm going to have to use quotient rule.